Hello, everybody, and welcome. This video, we will be going over the definition of the derivative. And while we do this, we are not going to assume anything in particular about the function other than that the derivative exists. And really, what that means is the function is continuous and the slope at any point only has one value. Okay, so again, in order to talk about a derivative, your function has to be continuous at x equal whatever the number you're talking about, x equal a, and the slope has one value, and it's real. Slope is single valued and real. Okay, so let's set this up. So I'm just going to draw a curve. Here we go. I'm going to start here, and I'm going to kind of just draw a curve, something like this. Okay. And the thing I'm trying to drive home here really is just that derivative is just slope at one point. That's all a derivative is. And what we're going to do is we're going to start with something familiar, something that all of you should know about, and that is the slope from Algebra 1. So I have two yellow points here, and let's say that the x-coordinate of the right point is b, and what should we call the y value? I guess we should call it, let's call it y with a b. The y belonging to the x value b. And here, let's say this yellow point here is x equal a, then y with an a. Okay? And what we can do is we can write down the slope between these two yellow points. That's what I'm going to do right here. So just from Algebra 1, it's just going to be, the formula is y2 minus y1 over x2 minus x1. And you know what? Just for simplicity's sake, let's actually change the name of these to match our little formula. Bear with me here. Okay. Good. So again, we're just gonna make this super simple. We're gonna call this x2, y2, x1, y1. There we go. So now everything is everything looks good. Okay. Now let's get into this. So this is just the good old algebra slope. Algebra slope, which means slope between 2 points. Okay? Good. Now, let's label a couple of things. First, x distance. Okay, so in other words, the distance from point 1 to point 2 in the x direction. So here's my x value. Now, this distance to this x value, I'm just drawing straight down from this point. This distance, this is the change in the x coordinate. And so we can call this delta x. This is the change in x. And in calculus textbooks, this is almost always called h as well. Okay? So the change in x is the same thing as h. H is the gap between the two x coordinates. And all it is, again, is x2 minus x1. Okay, that's all this is going to be. Good. There's that distance. Okay, and then there's another distance that's important, and that's the y distance. And to separate them, I will change my color. So we're talking about this distance. See, here's y1, and all the way up here is y2. Okay, so here's y2, here's y1. So this distance, this is delta y, which is just y2 minus y1, squeezing it in there. Okay? And similarly down here, with the x, with the difference in x's, there's x2, here's x1. Therefore, this distance has to be x2 minus x1. Okay, good. So these are the distances that we're talking about. And now what I want to do is I want to rewrite some stuff. Okay, so I'm not changing anything. I'm just rewriting stuff. Okay, so let's remember this is a function. This is a function of x. Y is a function of x. In other words, you plug x in, you do some math, and you get y. So what we can do is this. y1 is f of x1. y2 is f of x2. That's the first thing I want to do, is rewrite the slope in this way. Okay, so if I rewrite the slope, m equals, and then y2 is f of x2. So again, I'm just coming from over here. y2 is f of x2. I'm just substituting that in. Minus y1 is f of x1. Over, and then x2 minus x1. Well, look over here. x2 minus x1 we have already renamed as h. So wherever I see x2 minus x1, here it is. I'm going to replace that with h, which is going to be right here. Okay, so again, I haven't changed anything. This is still slope between 2 points. It just looks a little different than what you might be used to. Okay, we can rewrite some more. The goal here, by the way, the goal is to have this expression only involve a single variable. So here we have x2 and x1. We want to basically make this to where there's just only one of these x's instead of two different x's. So we can use this again. x2 minus x1 equals h. I'm just going to write that down here. H equals x2 minus x1. What we can do is we can solve for x2. And to do that, I'm just going to add x1 to both sides. And so we wind up with a fact that x2 is x1 plus h. And what this really means is pretty simple. That it means if I start here at x1, and then I travel a distance h, here's h, then that gives me that gets me to x2. That's all that's saying. x2 is x1 plus h. So wherever I see x2, I'm going to replace it with x1 plus h. And so I'm going to do that here. So again, slope, m equals f of, well, there's x2. x2 is x1 plus h. All right. Good. Now, look, both of these depend now on x1. One of them has an h in there, but that's okay. We've gotten rid of the x2. There's no more x2 here, because x2 is x1 plus h. So, again, I'm just rewriting. Still slope between 2 points. Nothing's changed. Okay, now, what's the difference between algebra slope and calculus slope? Calculus slope is slope between, slope at 1 point, slope at a single point. In other words, if I come over here, here's 1 point. I can quantify the slope at this 1 point, and we can draw a line, in fact. And the slope of this line that's touching this point is what we call the first derivative. Okay, now how can we obtain this? How can we obtain this line in blue? Well, what we can do is we can move x1 and x2 closer to each other. So in this particular little drawing that I have here, what we can do is we can take this yellow point that I'm now putting in blue, and we can move it toward this one over here. Okay, and so if we bring these closer together, so in other words, if I move this point over here like this, and then take this one and move it over here like this. So what I'm doing is I'm taking these 2 points and I'm moving them closer and closer together. Now, the thing to realize here is that I can do this forever. In other words, there is no a closeness that is too close, you know, because the real numbers have truly no gaps in them whatsoever. So I can bring these two yellow points as close together as I want without actually having them touch. In other words, you know, for example, H is the gap. H is the gap between x1 and x2. H could be 0.001. H could be 0.0000001. What I'm trying to say is that there's no limit to the number of zeros that I can put here before the 1. So that means that we can take these two yellow points and get them as close together as possible. And that is the idea behind this derivative thing, this calculus slope, this slope at 1 point. The way that we do it is we let the gap between the 2 points approach 0. We bring the two things so close together that you can't tell the difference between them. Okay? And, you know, coming out of Unit 1, in other words, we take a limit. Okay? So, to emphasize, this is algebra slope. Still algebra slope. The only thing that separates algebra slope from calculus slope is the following. Okay? And here we go. We get to the result. Slope at 1 point. Yeah. It has a few notations. Here's one notation. This little apostrophe is like we call it prime. F prime. There's another notation for it. dy dx, and we'll talk about that more in a minute. And we can also call it df dx because y is f. Y is f of x. These are just notations for it. And now let's actually write the expression down. So it's going to be the following. The limit as the gap, remember the gap is h. The limit as the gap goes to 0, as the distance between the 2 points approaches 0, of the following. F of, and now look here, we have x1 everywhere. x1, x1. What we can do is we can just drop the 1. So f of x plus h minus f of x over h. Okay? So the limit, as h approaches 0 of the expression, that limit is the only thing that separates algebra slope from calculus slope. Okay? And again, conceptually, it literally is just the idea of taking the 2 points that you know and love from algebra and bringing them so close together that you can't tell the distance between them. And the result that you get is this little line. The slope of this line is the first derivative. Okay? Slope here is the first derivative. Okay? So, yeah, that's just a run through of the general definition, the requirements involved, and the thing that I want to convince you of, the thing that you should walk away from this video understanding, is that the first derivative comes straight from what we know about slope, And the only thing separating algebra slope from calculus slope, or the first derivative, is this limit as the gap between the 2 points goes to 0. Okay, so that's the derivation. I'm going to call it here, and in the next videos I'm going to do some examples.